Most of you must have taken machine learning course from Stanford by Professor Andrew Ng, which turned out to be my first course in machine learning. Today we are going to recreate the first assignment, that is linear regression with one variable. In case you don't know what I'm talking about, you can go to Coursera and search for machine learning by Professor Andrew Ng, which turned out to be like the first course for most machine learning engineers. All right, we should open our CyxWiz Engine. From here, we should create a new project. We should call it linear regression and save it on our desktop. Okay, so our project is created. We should clear this graph. And in this video, I will use three approaches to solve this solution. The first approach is just to use the least square method from CyxWiz, and the next approach will be to use gradient descent, and the final approach will be to use our graph node and to see how we can build graph and train our main least square. All right. The first thing we need is our data. So I'm going to load the data under the dataset folder. Okay, so if you refresh our asset browser, we will notice there that our dataset is loaded. Okay, and now we should create our script, our Python script. In your script, just call it linear regression. Let me show you the equation that we will be solving. And this is the equation that we will be solving. So it says in this part of the exercise, you will implement linear regression with one variable to predict profit for a food truck. Suppose you are the CEO, in this case, we are machine learning, of a restaurant franchise and are considering different cities for opening a new outlet. The chain already has truck in various cities and you have the data for profit and population for the city. The question is simply, we are going to build a prediction model, which given the population, we should predict if output will be profitable or not. So we are going to predict the profit based on the population. It's like AX equals to B, right? That's a simple linear regression structure. All right, so we have created our new script called linear regression. By default, it comes with this boilerplate, which we can clear it. And then under our script editor, we have view. We have something known as notebook mode. So if you're familiar with Jupyter Notebook, it's something similar to that, but it is still under development, so it's not well structured. Okay, from here we can start editing by importing the various packages that we need in order to build this assignment. Oh, before that, before building your assignment, it is always good to look at your data. So let me open our data set. This is the structure of our data set. Column 1 is the population and column 2 is the profit. All right. We are going to train a model that when given the population is going to be able to predict the profit. Let's start importing our packages by import by CyxWiz as CX. One correction I want to make is if you have checked the documentation of CyxWiz from the link below, we notice that in the documentation it says import CyxWiz, not by CyxWiz. So just know it is by CyxWiz. We will update the documentation. Apart from that, nothing changed. All right, numpy as np, import matplotlib, because we are going to plot our data as pyplot as PLT. All right, we can run our cell. Okay, our cell is running, and we should open our command window to see what is happening. In this version that I'm using, which I'm going to upload, the link will be in the description. You will notice that when I created a new project, we have a new folder which has been created called Python, and here it creates a virtual environment for us. It is currently under development. Probably by the time you download it, I think it will be implemented already. When you import anything, it should be able to like look at it here so that it should not mess up with your system packages. All right, I think that is it. Now the next thing is to load our data. So we can create a markdown. If we want, we should put it up, edit our markdown. All right, now to load our data, we are going to use the data loader from CyxWiz. So we use loader is equals to cx dot data loader. From here, we are going to load our data, which is equals to loader dot load CSV. This is not a CSV file. We notice here that this is a text file. Okay, but it is a comma separated, so it is going to work. CSV and our data set ext1 data 1. From here we use columns in order to pick the column of the data we want. We have col 1, b is equals to, the column is column 2. Okay, now we have an error. One thing you have to notice is our data loader function is actually using docdb. So if you notice, if you're familiar with docdb, you will notice that it is memory efficient. So I think there is an error somewhere. So let me check what is the issue. So after we load our data, now we are going to convert our data to numpy. All right, simply because CyxWiz is still under development, and the function we have implemented so far uses numpy. After we load our data set, all right, using our loader function, we convert our data into numpy with the type as float64. If we come here and we print the type of A, we will notice here that this is a tensor, and we notice that this is a CyxWiz tensor, and if we convert it to numpy, we notice here that this is a numpy array, and we print our data. So we have here on the side bar, we can load the various variables which is being used in our system. So from here, that means if I come under our Python command print x, it knows the variable, so you can use it from down here. Oh, we have a bug somewhere. Okay, I think when you open the variable menu, there is a bug which which we are going to check later. After loading our dataset, we need to train our model. Before training our model, we need to insert a bias in our X array. Okay, so for us to do that, we just use numpy and say x equals to numpy dot insert x from colon 0. The value is 1, and the axis equals to 1. We have added the bias units. Okay, compute our parameter or the weight by using theta. From the example is theta, and here is very simple. We use LA now. Import by 6 dot linear algebra as LA, right? And from here we compute our theta value by just using this one line, LA dot list, where the value is xy. So that is it with this, and we can print theta. So this is the value. All right, we have computed our theta. Now what is theta? Theta is our weight, or in other words, is the parameter, all right, of our model that is going to help us predict the profit. Let us test our theta value on this data set, assuming that we are given a population of 1.8. all right, so we have normalized it. Okay, and another one, we have given a population of 2.5. Using our theta that we computed from here, we should compute the profit and see. So if we run our code, now the function we are going to use is la.mathmul, that is multiplication. So it's going to be our prediction times the theta. If we check the output, we notice here that there will be a loss, but with a population of let's say 1.8, we notice there's a loss of minus 17,000, and with a population of 2. We notice that the population 2.5 is greater than this, right? So the loss is a little bit is lesser than 17,000. I went ahead and coded everything just to save time. We want to visualize our theta on our data set to see how it works. So what I did was I use mp.linespace, and I fill 100 value from 10, from minus 10 to 10. All right, the same thing from minus 4 to 4, 100 value. So this should be our theta 1 and our theta 2. And from here, we are going to compute the cost. All right, and yeah, this is more like a brute force search on theta. If we come and we plot the graph, so we have this nice graph here, which we are going to search for the value of theta. All right, and for us to search for the value of theta, so the value of theta is a value that is going to minimize the cost. So assuming you're here, you are going to search. This is more like a gradient descent algorithm. So you're going to search and look for the value that is going to minimize this. From this mp.array, we initialize our theta to be from a value between negative 10 to 10 and theta 0. between negative 10 to 10 and theta 1 between minus 1 and 4. The theta we computed here was minus 3 and 1. All right, so that means if we looping from theta 0 and theta 1, we are going to find the theta that is going to minimize the cost. So in our next video, in the next sample, I'm going to show you a simple gradient descent that is going to be used to compute the thetas. If we use a contour plot, print the theta, we notice here that this is the minimum point. We are going to use the theta we computed and plot it along our data set. Okay, so if we notice here that we take our scatter plot, that is column 1, we mark it as x. Okay, then from here now the value of y, which is going to be theta 1 times value of x plus theta 0. Okay, this is our y hat, the y hat that we are projecting. The blue line tries to minimize the distance between the data point. The main takeaway from this tutorial is just these two functions, which is our least square, right, that computes the least square, and also this math mole that multiplies. I think that is the most important function from CyxWiz. Apart from that, everything is just Python code and using matplotlib. All right, so let us use another approach, that is gradient descent.